Assalamu alaikum, good afternoon, welcome. Thank you for coming to this session. Delighted to have you here. My name is John A. Sweeney. I'm a senior research fellow at Westminster International University in Tashkent, Uzbekistan, and I have the privilege of moderating this session. I'm delighted to be joined by some amazing speakers, and we're going to have, hopefully, some conversation time, and we'll come back as well to the QR codes. So without further ado, I would like to introduce our first speaker, who, if you've been here, is no stranger to you, Okorafor,
yes.
An award-winning science fiction author and writer. Nnedi, over to you.
Okay. Hello, everyone. How's everyone doing? Okay, quiet. All right. So I'll just start in. I kind of wrote out what I'm going to say because I want to keep my thoughts, keep them in an even thread. So my point of view on this is not as an expert on terraforming. It's as a science fiction writer, an expert storyteller who speculates and extrapolates. So much of science fiction speculates about the future, from technologies to societies to socio-political issues. The genre is obsessed with the question of what if. It's also simultaneously about the question of what is. It's about who we are today, and it connects to who we will be or can be or don't want to be in the future. It's a form of storytelling that deliberately looks into the future, invents technology, and explores beyond Earth. A key component to progress is creativity / the creative, or the imaginative. So science fiction has a role to play, and it belongs at this conference. So terraforming. It is to transform a planet or a body in space, like the moon or an asteroid, so that it resembles the planet Earth. What we're most interested in is transforming it so that it can specifically support human life. Now, why consider terraforming? That's where things get interesting. There are the obvious reasons. Terraforming other planets or moons or asteroids will create another place for humanity to migrate to if Earth becomes uninhabitable due to climate change or something faster like nuclear war or an asteroid collision. But also, maybe some answers to climate change lie in figuring out or researching how to terraform Mars or Jupiter's moons or an asteroid. Maybe the only ways to figure out Earth's issues is to make the issue 100% foreign again, make it new so that we can look at our planet's problems with fresh eyes. And this is something that science fiction naturally does, so I recognize this possibility. One thing that I hope we address on this panel are the ethics of terraforming. In the past, we've treated this Earth like a thing to be colonized, that everything on this planet is for our use and consumption. I believe that is a big part of what led us to be here to this issue of climate change. We overuse, we don't respect, we think of this planet only in terms of ourselves, not with humanity merely being a part of a complex ecosystem. So one of my questions is, how do we not repeat our mistakes? How do we do better? And I know this might be throwing a bit of a monkey wrench in what some of you guys are going to say, but it is what it is. We're eyeing Mars now, but have we learned? Are we ready? Or will we just play the colonizer again? Remember, terraforming is not science fiction. We've done it before. We've done it to the Earth already. And look how that turned out. So as a science fiction writer, I don't claim to have a lot of answers, but I have a lot of questions, and I'm interested in starting conversations, which is why it was good that I went first.
And thank you so much for starting us off, I think, in a space where exactly we wanted to go. So holding the ethical, moving us to be able to discuss questions around inequality and access are precisely where we want to move. But we also have a range of speakers that are going to different topics. Of course, as we are in this space, it's hard not to see and feel the artifacts of what it might be like actually to have this multi-planetary species, but also to think about the constraints, right? Who is in those futures and who's not. So with that, I'll turn it over to our next presenter. Dr. Chuanfei Dong is a staff scientist at Princeton University, and he has some slides to share with us as well.
So hello everyone. Maybe I can.
Space to take a moment to get the slide. Okay, there we go.
So today's, so I will briefly talk about how can we make other planets livable in our lifetime. And today's my presentation will mainly focus on Mars because a lot of spacecraft have been sent to Mars, including the Hope spacecraft from the UAE. And the terraforming process is basically we want to make Mars Earth eventually. And to give Mars a thick atmosphere. But in order to make Mars Earth-like, we first needed to find out why Mars become so cold and dry today. So the question we want to ask is where did the water atmosphere on Mars go, transforming Mars from early wet water to the cold and dry. Hello, yeah. From the cold, from early warmer wet water to the cold and dry state existing today. And the NASA's MAVEN spacecraft actually offer you an answer.
The most likely cause of this process is the solar wind, a stream of electrically charged particles blowing from the sun. When the solar wind reaches Mars, it interacts directly with the upper atmosphere, piling up ahead of the planet in a bow shock. Charged particles from the Mars upper atmosphere, seen here in color, fill the pole of the electric field.
And those color particles are the oxygen ion escaping from Mars.
Ions can pick up sufficient energy from the electric field.
And those are from simulation. And as you can see later, we also have spacecraft measurements and the simulation results and the spacecraft observation agree with each other reasonably well.
Now, data from MAVEN are supporting this model of solar wind erosion. This graph shows the first ever measurements of oxygen ion flux around Mars, allowing us to see the solar wind driving the atmosphere into space in both the polar plume and the tail regions.
And I want to mention today's Mars has no global magnetic field. You can understand this process as how you dry your hair during your daily life. And so I want to give you a little bit of background. The charged particle, when the charged particle move across an array of magnetic field, the trajectory will be banded. And the solar wind are basically charged particles streaming away from the sun. So back to 2017, Jim Green at NASA headquarters, together with myself and a few colleagues, we proposed to place a giant magnetic field ahead of Mars on the Martian Lagrange 1 point, about 330 Mars radii ahead of Mars, such that the Mars will be located in the Martian magnetic tail. And if we reduce the atmospheric escape rate from Mars, and we assume the current Mars has a surface equilibrium, basically the outgassing rate will be balanced to the escape rate. So if the escape rate is reduced, then the atmosphere can gradually accumulate on the Martian surface. And I also want to point out there's a CO2 ice layer in both southern and northern Martian polar region. And beneath the CO2 ice layer, there's a lot of water ice. So if the temperature increase initially due to the accumulation of the atmosphere, and the CO2 will be melted, and the CO2 is a greenhouse gas, so the temperature will keep increase, and eventually the water beneath the CO2 ice will also be melted. So the key idea here is to reduce the atmospheric escape rate from current mass. And here's the simulation result. We find if we put Earth-like magnetic field ahead of Mars, the atmospheric escape rate on the Martian at Mars can reduce by a factor of 10 during those extreme space weather events. And here's a 3D view, and Mars is very tiny on the left up corner. Maybe you can see that. I will skip this animation. But recently we find there's another more efficient way which can reduce the dipole strength significantly by a factor of 10. And we can put a 4 dipole magnetic field at the aerostationary orbit around the Mars. You can understand the aerostationary orbit around the Mars like a geostationary orbit around the Earth. And if we put 4 dipole around the Mars, and the strength only needed to be 1/10 of the Earth, and which can significantly reduce the atmospheric escape rate. And I also want to mention those magnetic fields can also protect the Mars from those high energy particle radiation, like the cosmic ray and the solar energetic particle. We are trying to do some preliminary study, try to study how to protect Mars from the solar wind erosion process, and eventually make Mars more Earth-like to give Mars a safe atmosphere. Thank you.
Thank you very much. So as we move from the why, the conceptual, the philosophical, the ethical, to the how, the deeply technical, I think some of these questions, of course, don't go away, but become more prescient and more critical. Certainly looking at the models, it's quite dynamic to think about, oh, there we go, I'm mic'd now, about the feasibility and the probability of deploying this tech. And I know we're going to hear about a bit of that from our next speaker, Dr. Nidhal Guessoum, a professor of astrophysics at the American University of Sharjah.
Thank you very much. Good afternoon. Assalamu alaikum. I want to stress that I am an educator first and foremost, and I am also a science communicator. Some of you probably in the audience will be familiar with some of my books and writings. The reason I say this is because for me it is extremely important that we bridge the science fiction, the research, and BRSC, the education field, and the general public to understand all these. When we talk about space, and especially space exploration, thank you. When we talk about space and space exploration, the moon, Mars, terraforming, which everybody will tell you will not happen for a few centuries, the immediate reaction that we get from students with whom I spend a lot of time every day, and the general public, I am on Twitter, on Facebook, my lectures, YouTube, etc., is why are we wasting so much money, effort, time, brain on issues that have zero relevance to us, that are not going to occur for the immediate future, and we have some serious problems to address here on Earth. And I strive to explain to everybody that these topics are of importance to us, all of us, today, tomorrow, and in the near and far future. So let me just say a few things about the exploration of the moon, the exploration of Mars, the impact that it has on humanity, since we are talking here about the future in this forum. One thing we need to understand is that space is a very near frontier, it used to be called, and it is no longer a frontier. The definition of space is, or this frontier, this boundary of space, is 100 kilometers above our heads. 100 kilometers. This is less than the distance between Dubai and Abu Dhabi. So that's just to give you an idea. Now, you may say, yeah, but the issue is not how many kilometers it is, how easy or how hard it is to make it there. And that's why it took some time to develop those rockets and launching rockets, the fuel that it takes, how many kilograms you can put in space, what it takes to go to the moon, to go to Mars, and the radiation that exists in space, etc. It is the physical conditions in space more than just the distances. And that is part of the education that we need to bring to the general public and to students, why space is hard. But space is getting easier and easier, and with the ease that we are developing, development of large technologies, development of new companies, new ventures, until maybe 10, 15 years ago, space was the avenue or venue only for government agencies. It used to be NASA, ESA, the Chinese Space Agency, the Russian Roscosmos, the Indian, and then it became SpaceX, and then it became Blue Origin, and then it became Virgin Galactic, and then it became, and it is growing and growing and growing. And some of these companies are not doing it just for space exploration, meaning for the science of it. It is for benefit, and with that benefit, it develops new technologies. You've seen SpaceX now has developed this incredible quantum leap in rocketry that you can send a rocket to space and bring it back and land safely, use it again and again and again, slashing the costs by a factor of 5 to 10. The other thing I want to mention is that space will very soon become an economic, we might even say battleground, or at least competitive ground. There are companies and national agencies that are now readying to go and get some very valuable chemical elements from the moon, from asteroids, and those are extremely valuable monetarily in terms of cost and in terms of how much how abundant they can be on the moon, for example, or on asteroids. China has already mentioned that it will be mining the moon for helium-3, bring it back to Earth to use it on small reactors, fusion reactors. Fusion reactors are widely understood to be the next game changer. Now, this will happen in maybe 10, 20 years, 50 years at most. There's going to be nuclear reactors that will be able to break even and produce energy with nuclear fusion, not nuclear fission. And that will change everything. And nuclear fusion is most easily done with helium-3, which exists in much greater abundance on the moon and on asteroids than on Earth. Now you might think, but that's going to be very expensive because you have to be on the moon and then mine it, or on asteroids and then get back here or bring it back here. One thing that I tell my students, and this is relevant to everybody, it is cheaper to send a rocket from the moon to any satellite here around Earth, even those that are just a few hundred kilometers around us, or a few thousand kilometers, or even the geostationary satellites, which are 36,000 kilometers above our heads, those that we use for telecommunication, for TV satellite stations, and all of that, 36,000 kilometers above our head. The moon being almost 400,000 kilometers, it is easier and cheaper to send a rocket from over there to here. And with that comes even a military, very important application that we have to be aware of, that you can shoot a satellite revolving around Earth from the moon much easier and much cheaper than you can shoot it from down here. And there have been a number of accidents or attempts or trials of shooting satellites from here for strategic applications. I just wanted to touch a little bit on how space now is becoming strategic in the economic, military, educational, people who are going to be living for extended periods of time. We have already had astronauts who have spent more than a year on the space station. We're going to have people who will be spending months and years on the surface of the moon. We're going to have people within 10, 20 years spending months, years on the surface of Mars. And just to conclude with the issue of ethics, for example, terraforming. People started thinking of terraforming in the early 60s, at least thinking of it scientifically, writing papers as to how to do terraforming, how to transform the surface and atmosphere of a planet or even the moon. And then people realized that with the development of synthetic biology, So there's a completely different field. Now you can make some plants to be more efficient and more surviving the radiation of the moon and Mars, while at the same time more able to absorb the CO2, produce more oxygen, live in water, inabundant, I was going to say, or dry places. And so there's some genetic engineering involved, there's some transformation of these places. There are so many issues. It is not just, terraforming is, 500 years down the road, and we're not going to be able to transform Mars, or maybe we will have to really change its magnetosphere and stuff like that. People tend to think of terraforming as science fiction, excuse me, and I love science fiction. But I just wanted to explain that all these issues are of relevance from so many angles, from ethics, from politics, from military, from economics, from education, and this is going to haunt us for the years to come.
Thank you so much, Dr. Guessoum. So we began with the why and the ethical, and we moved to the how and the technical, and now we see the geopolitical and the strategic and that blending. Finally, we'll hear from the operational. And so we're delighted to have His Excellency, Salem Al Marri, the Director General of the Mohammed bin Rashid Space Center, talk about what is a very exciting time with regards to space and UAE.
Thank you very much. Assalamu alaikum. And I think today I'll try and put in my talk a few hats on, or a few ugals, as we see. This black one is called the ugal. So I'll start with my first hat, which is, as you said, the operational. So from a person who is, let's say, a Director General of the Mohammed bin Rashid Space Center, which is an operational, a practical center that exists here in Dubai in the UAE, which is in charge of human spaceflight for the country, Mars exploration, moon exploration, Earth observation satellites. So we are really in the business of developing missions. So if we talk about this topic from that perspective, so what would I look at it as a person who is in the government? We're always looking at, number one, what is the cost? What is the time schedule? And how practical this is. Of course, we try to do cool, exciting things, but eventually these things, whenever you're looking at it from a government or a private sector, you're looking at those elements. And there's another element as well, which is why you would do this. So from a practical perspective, you can think that there's two ways that you can go and live on the moon or on another planet. One of them is by terraforming it, so trying to create a replica atmosphere of what my colleagues have been talking about here, of something that's similar to Earth, so you can breathe and live on that planet as if you were on Earth. Another way of doing it, which is you are able to live on that planet, but you're living in your own structure. So this is what maybe we would look at it from our perspective is, how can you get to the moon and get there in a sustainable manner and do that in the next 20, 30, 40 years? Do that in a cost-effective manner. The way we would think about that is what's happening globally currently. So if we look at the global exploration roadmap, it is let's say a direction from the global space community of how can we get back to the moon and then use that as a springboard to go to Mars and do that in a sustainable manner. So the first element is to build a space station similar to the ISS around the moon, and that's what's happening today. Then the second element is to have a practical way of going from that space station down to the surface of the moon. And the third element is, what are you going to do on the surface of the moon? Where are you going to go? So there should be some sort of house or some sort of area where astronauts or explorers can go to the surface of the moon and conduct science or exploration or mining, whatever so for me, from a practical perspective, if I have my practical hat on, this is what I see as something that would happen in the next 30, 40, maybe 50 years. And then shifting that, what we've learned around the moon, which is relatively close, so a 3-day trip, a time delay in terms of communication of seconds rather than hours or minutes, moving then towards Mars and trying to do it there. So going to Mars is a totally different story. It's a 7 or 8 month, 9 month journey. Just to communicate there's a signal delay of 10 to 30, 40 minutes. Just think about that. And then, of course, getting the signal back. So if you want to say hello to somebody, you might get your hello in another hour or something like that. So that is not an easy way to survive on Mars. So I think you've got to learn around the moon and then try and move to Mars. And my perspective is, in 50 years, a lot can happen. So I can use two examples of this. One of them is the UAE. His Excellency Mohammed al-Gargawi said yesterday, from no roads in 1971 to Mars in 2021. So 50 years, we went from no roads, no cars, to Mars. That's an example of the UAE. Another example is from the first powered flight, which is the Wright brothers on a biplane, towards landing on the surface of the moon was about 60 years, 65 years, 66 years, something like that. So tens of thousands of years of human history, we never flew, we never had any powered flight, and in pretty much half a century, we went from flying to the surface of the moon. So I think in that period of time, which is 50 years, a lot can happen, and I can see us having a sustainable presence on the surface of the moon, and eventually a sustainable presence on the surface of Mars. Now, if I take this off and put my other hat on, which is, I would say science fiction, but there is science behind it. There is, which is terraforming a planet and going into trying to change the atmosphere of a planet. I think the science is there, it can happen. I believe that this is something much longer term. I believe it would, if you're going to put a shield, or if you're going to bombard the moon with the ice particles, if you're trying to do those types of elements, the amount of investment, the amount of human brain power and commitment would be on I think every country in the world needs to be involved in that type of terraforming solution. And I think nothing would drive that except a strong need, so that there's an asteroid coming, or there's something, as you mentioned, that would really push us to do something like that. But I think, again, the timeline from I'm not an expert, but what I've read is we're talking hundreds of years, potentially longer, to terraform a planet into something that's livable. So those are my opinions. Thank you very much.
Thank you so much to all the panelists. I'm sure there are questions. I think I'd love to hear, are there any reactions or reflections from any of you based on what you've heard? We covered a lot of ground, from the ethical to the technical to the strategic to the operational and back again. Was there anything that stood out to you? Is there anything that we're not talking about, or anything else that you'd like to bring forward? And maybe, please.
It's not quite on subject, but I was listening to what you were saying about the various possibilities. Like there's terraforming a planet for human beings to be able to live on, and then also creating these structures. But there's also a third possibility, and this is completely off subject, but I guess it's connected. What about genetically engineering and genetically modifying human DNA so that people can live, better survive in space? So, for example, maybe altering DNA, and I was reading about somewhere where they were looking at adding an extra chromosome so that it would be more like a receptor, so that it could add different capabilities to a person. And one of the first one that there was the most concern with was the ability to withstand radiation while in space. So I mean, that would be a third. So where there's the need to change the planet, what about the need to change ourselves so that we can survive out there? So yeah, I don't know where.
Can I say something on the, just to stress again the education aspects of this? I mentioned that, but I want to really stress it again from two perspectives. One is the inspirational power of space. Everybody knows that kids, when they look at a rocket going to space, when they look at satellites, when they look at astronauts, they all want to become astronauts. They all want, perhaps the best birthday gift is an astronaut suit for a kid, right? And that's really inspirational, and it has led, so many people have said, I ended up in neuroscience or in genetic engineering because at the beginning I wanted to become an astronaut. And then it wasn't possible because my eyes aren't too good, or I have a heart problem or whatever, and so I decided to study cells or to study something else. The other thing I want to say, and this is important, that we feed into the education system all of these ideas, including, I mentioned to you yesterday that when some years when I was teaching astronomy, I made my students read some science fiction novels of Arthur C. Clarke. So it feeds into each other. But the other thing I want to mention is that, you know, there are so many schools from elementary school all the way to university where the kids construct satellites. At my university, this is not a feat by any measure. I think it was 7 or 8 years ago, the students built a small CubeSat, and it was sent to space on an Indian rocket, which at the time, and that too was not a big feat, had carried over 100 small satellites in one launch. Students are always working. I had students build an antenna to receive signals from a meteorological satellite and to analyze it and do data processing. And they felt like it was fascinating that they were getting these meteorological data. They were analyzing, looking at the weather reports, sort of making weather reports on the fly as they were. This field is extraordinarily powerful in producing what we call a knowledge society or a knowledge economy. And I think that's a message that we need to send across.
This brings us into a space to consider the imaginary, the future. Push. I see. And it's hard not to feel that when we're in a room like this. Which I think is precisely this question around if we think about it alternatively. And there have actually been propositions by scientists to say that, and these were just asking what ifs, what if we enhanced human empathy as a means to combat climate change? And so I think these are the questions. So now we've added the educational and the question. Hopefully I can get the mic to question. I imagine that there are some questions. So I saw a hand in the back here, and then I saw a hand come up here. We will have some questions come forward. So, okay, let's go here first. The mic is here, and then we will come back to you. Please.
Thank you, guys. I really appreciate your... I always have my in-laws, and they always say, Mars, what's the point? Space, what a waste of time, fix Earth's problems. And I always say, thinking I'm so clever, well, for the moon mission, so many technologies were developed that helped us here on Earth. With your knowledge and insight for all of you, can you share a little bit about that if you don't mind? If you have any examples you can think of that could be useful for us to learn from. Thank you, guys. And go Mars mission, woo!
Would anyone like to respond? Tech, please.
Thank you, that's a good question. And I think I'll answer it in two ways. First of all, what Professor Nidhal here mentioned, which I think a lot of people look for what is the benefit of space. And then is that a technology that I can use now on Earth? That's not necessary, yes, that's one way. And I'll talk about that. For me, the more important way is a lot of it is inspiration. So today we can inspire kids to think bigger. We can inspire kids to go into STEM fields. We can get them into engineering and mathematics, etc. And then hopefully, they might not work in space, they might not be astronauts, but they're going to hopefully want to do amazing things and good things. So that's one benefit. Another benefit is the direct benefit from space, which is today you send satellites for navigation, you send satellites for communication. All of you here used a satellite today somehow when you got here, whether it's through navigation, whether it's through mapping on those navigation devices, whether it's communication, whatever it may be. And you've used some sort of space technology. And then the benefit that you mentioned, which is spin-off technologies, or technologies that were developed specifically for space that eventually spun back to Earth, and we got a benefit from those. And there's lots of these. Some of them are, filtration devices, water filtration devices. Previously, there were not the technologies developed to kind of extract water and be efficient with water and filter water. But go to space, water is heavy, and it's one of your most important elements to stay alive. And then the way you filter it, the way you the way you use it is important. Today, those types of technologies are used on the ground. That's one technology. I can tell you that there are thousands. And that's an unintended benefit from space. Of course, the fourth element is the direct technology that we develop to go to space. I mean, that itself is something that keeps me in this job. So we, will always try to do something new that's never been done before. Go to the moon in a different way and go to Mars, as you said. So today we're building Rashid rover, which will launch in about 30 days to the moon. This is going to be the first object from the Middle East to go to the surface of the moon. And it's going to be the smallest rover ever built. So when you miniaturize technology like that, there's a lot of development, a lot of risk you take, and a lot of excitement. We might not succeed, we might succeed. I'll knock on everything here to hopefully that we succeed. But the journey of developing new technology and miniaturizing that technology is exciting for us as engineers.
Wonderful.
Rohit had a question. Do you have a mic? In the back. In the back, and then we'll come. Oh, sorry. Yeah.
Thank you. Fascinating, and as a nerd about space, I loved everything that you were saying. I guess for me, one of the questions is, if we were to colonize, how do we design the operation of those colonies, the governance, the societal models, how we do dispute resolution, what the right structure is? So Elon Musk talks about a Muskocracy where he makes all the decisions, Asgardi has had all sorts of conversations. Have any of you done that kind of thinking of sort of how many people we need to have diversity and ensure the future, and how we would govern in that kind of environment? And would we have a completely new model of government, completely new models of legal regulation for that kind of world?
I'll say a little bit. That's certainly something that I've but I'm not an expert. But those are questions that I have, and that's why I say I bring a lot of questions to this, because that's you need the diversity. You're gonna need diversity in the types of people that are going to be there. You're gonna need diversity in the types of governance, the types of thinking, the types of philosophies. These are really important. And one person, Elon Musk, he's very smart, but one person isn't going to know all of this. And from a science fiction perspective, the way that I come at it is I think there need to be a lot of different voices. If I were to speak to the scientists who are considering these things, because I'm sure they are, one of the things that I'd hope that they would consider that we're going to need a lot of different voices and points of views to participate in how to come up with all of that.
Thank you, Rohit, for finally confirming to me why I'm moderating this panel, because I wasn't entirely sure until this moment. So at the University of Hawaii at Manoa, where I did my PhD in future studies, the undergraduate Futures and Foresight class is Governance Design for Mars. And that class was run by Dr. Jim Dater for decades, and it was completely unique. And so I think to turn this question around is, why aren't we actually having that further conversation? Of course, a number of futurists here are doing lots of educational work, but thinking about the opportunity to use something like that, to use that challenge of governance for a different space, and to think about bringing that forward. And so I think that is an interesting provocation as we continue the conversation. So thank you. Please, there was a question here.
Yeah, thank you very much for this fascinating discussion. I have two roles, prof and chief scientist. So I will have some comment to the science and education, and another comment to the operation. So for speculation, and I served in different national labs in the United States, so I know what I'm talking about. Simulation is speculations. So we need to be careful. Also believing in hope. I truly believe in hope and distribute hope. The operation is really, the operational perspective is right. And one thing here I'm asking, scalability. How can we scale that? Now, whether we, as I mentioned, simulation and speculation, there is a lot of things need to be done. I trust that. But when it comes to the scalability, I trust it's also not easy. So how could we scale this if we manage to have it done successfully as we hope? Thank you.
In my presentation, I initially showed the dipole ahead of Mars about 330 mass radii, and that requires an Earth-like dipole. But we realize it's highly challenging to create such a huge magnetic moment. So recently, we also proposed to put 4 dipole around the aerostationary orbit around Mars, which reduced the dipole mass distance from 330 mass radii to 5 mass radii, so which can significantly reduce the dipole strength. Based on the preliminary study, we find only 1/10 of the previous magnetic field strength can achieve better efficiency. And I agree, it's still highly challenging to create such a huge magnetic field. But with the human technology development, and especially those superconductor, so we can always rely on the solar energy to create current. And the magnetic dipole strength is proportional to the current loop area. So if we can use a balloon to expand the current in the space to create a huge loop, and the current can automatically generated by the solar energy through superconductor. So we find it's possible, I would say, but I realize it's still takes some time to test those scaling relation in a lab first. But as a human, we should we're always curious about the future technology, and I think it's the right way to give everyone a hope to terraform a planet in the future. I also want to briefly mention terraforming has different meaning. As my colleague mentioned, the one I mentioned is globally change the Martian climate. But we can also locally change the planet's climate, even the lunar climate, in a local habitable area. That will be much easier than you terraform a planet globally. So with the local terraforming, then I feel it can be achieved much earlier. Maybe the time scale can be maybe 30 to 50 years, as my colleague predicted. I also believe that can happen. So, with different technology development, we can achieve different goals at different scales. So maybe, the first goal we can achieve is to locally terraform a planet. That will be much easier to achievable in our lifetime.
Thank you for your question. And to answer maybe the scalable approach, what I would say is, why haven't we been back to the moon for 50 years? And I think bluntly, simply, a big element of it is the cost. So the cost, is $200–300 billion to go to the moon. So what I said in my segment was that of course, the way that we should be doing it now is in a sustainable way. So the cost should be spread over many countries. It should be a sustainable approach that we are reusing to save those costs. Now, your question is about scalability. So how does that grow? And I think, again, that comes back to cost. So governments, in my opinion, can sustain it at a level like the ISS, like what you see with the Chinese station and the Moon Gateway. Governments will sustain it at that level because of science, because of exploration, because of the engineering, etc. If we want to scale it where we've got 1,000 people living on the surface of the moon or 2,000 people, I think the element there would be, is it profitable? Is there some reason that we want to have that many people on the surface of the moon? And can we make that in itself pay for itself? So then you'll start to get commercial companies involved, etc. Of course, we have people like Elon Musk that want to do it for the sake of doing it, and they're interested in that. But in a long-term thing, I think there should be some profitable way where companies can make money out of being on the surface of the moon. That's how it'll be scaled up and go from there, in my opinion.
And I know there are further questions, but we are almost at time. I would love to have the questions put back that we asked, the QR code, and we could have a look at this. Please try to catch the panelists if you have any further questions, but we are almost out of time. And so To return to this, the question was, how important is it for humanity to render other planets inhabitable in the next 20 years? That received a 6.1. How likely are we to achieve meaningful progress in the next 20 years? A 5.6. So some agreement. Please help me in thanking our amazing panelists. Clearly the challenge is not here today, but if we've raised additional questions and specifically we've thought more deeply about the future, then I think we've all succeeded. So thank you so much for coming, and please help me in the panel.